Modern vehicles require a stable 14.2 to 14.4 volts from the alternator to power their complex electrical systems. This voltage range is critical for proper operation of all electronic components. These electrical systems include advanced infotainment systems, electric power steering, LED lighting, multiple engine control units, and advanced driver assistance systems. Each component depends on stable voltage to function correctly. When an alternator outputs only 13 volts, it creates a significant problem. This voltage is insufficient to meet modern vehicle demands and indicates a malfunction in the charging system. Several internal alternator components can cause low voltage output. The voltage regulator, which controls the alternator's output, is often the primary culprit when it fails. Worn carbon brushes and slip rings are another common cause. The brushes make electrical contact with the slip rings, and when they wear down, the connection becomes poor, reducing voltage output. Diode failure is another critical issue. Alternators use diodes to convert alternating current to direct current. When diodes fail, they reduce the alternator's output capacity and can be detected through proper testing. Stator winding problems, including open or shorted windings, can also reduce alternator capacity. The stator contains three-phase windings that generate the electrical output. External factors can also cause low alternator voltage. Belt tension problems are common. If the serpentine belt is loose or slipping, the alternator cannot spin at proper speed. Corroded battery terminals create high-resistance connections that can cause voltage drop and affect alternator performance. Clean, tight connections are essential for proper charging system operation. Poor ground connections throughout the electrical system can also contribute to voltage problems. Corroded or loose ground connections create resistance that affects the entire charging system. Modern vehicles continuously monitor their charging systems through onboard diagnostics. This means that alternator problems are often detected early, but they must be addressed promptly to prevent cascading electrical issues throughout the vehicle. Diagnosing low alternator voltage requires a systematic approach. The first critical step is performing a battery load test to ensure the battery can properly accept a charge. Next, perform voltage drop tests to identify resistance in connections. High resistance in cables, terminals, or ground connections can cause voltage loss that mimics alternator problems. Use an oscilloscope to analyze alternator output quality. This reveals AC ripple patterns and regulation stability that basic voltage meters cannot detect. Excessive ripple indicates diode failure or stator problems. Perform a comprehensive charging system load test. This evaluates alternator performance under actual operating conditions and reveals problems that only appear under electrical load. Once diagnosed, repair strategies focus on component-level fixes. Replace specific failed components like voltage regulators, brushes, or diodes, rather than the entire alternator when possible. Ensure compatibility with vehicle electronics. Prevention is key to avoiding future problems. Inspect belts every 30,000 miles for proper tension and wear. Clean terminals annually and perform biannual charging system tests. Keep vehicle firmware updated for optimal system integration. Watch for these warning signs of charging system problems. Voltage readings consistently below 13.5 volts, dimming headlights at idle, battery warning lights, and electrical system malfunctions. Early detection prevents costly breakdowns.